Okay guys, so let's take a look at a recap of transformations. The first thing that I want to do is I want to go over all of the parent functions that we did in transformations throughout all units. I'm going to show you all the base functions and the x-coordinates of, suggested x-coordinates, I should say, of the key points. So in Unit 3, we had 3 main parent functions. One of them was a quadratic, so x squared. One of them was a square root function. And the last one was a rational function, 1 over x. Okay? You do not need to memorize the x and y coordinates of all of these points. If you have a good idea of some x's to choose, you plug them into the equation and you generate the y's. Okay? There's no need for you to memorize both. So, does anyone remember some good x's that we can use for the quadratic function? Chris? Okay, -2 to +2. That gives you the right side of the parabola and the left side of the parabola so that you have that U shape. Okay, what about a square root function? What would be good things to choose if I'm going to square root them? Sia?
0.
Perfect. Perfect squares. So when I square root them, I'll get whole numbers. Again, if I'm trying to generate the y coordinates that go with these, I'm just going to plug them right into the equation and then I'll make the y coordinates for those points. So I'm not going to go over those y coordinates. How about the 1 over x function? This one's a little bit different. Josh?
-2, -1, -0.5, and 0. Like the opposite.
Not 0. Why not 0? Why can't I choose 0 for this one? Makes the function undefined. So there's 2 extra pieces of info for this type of function then. It's the horizontal and vertical asymptotes, right? The horizontal asymptote is at y equals 0, and the vertical asymptote is at x equals 0. And these are caused from restrictions on the domain and range of this function. So those were the Unit 3 functions. We also did 2 exponential functions in Unit 4. We did 2 to the x and half to the x. And these ones are really easy to remember because they're the same x coordinates that you would choose for the quadratic function. So if you just choose -2 to +2, and then you sub them into the exponent in these equations, so just to clarify, this is an exponent, you should generate your y's. And it's actually the same for both of them. So super easy to remember those guys. Get a little bit on the left of the y-axis, a little bit on the right. Okay, and then the last ones were sine and cosine. These were from Unit 6. And I think these ones should be pretty fresh in our memory. What are the x-coordinates that we use for sine and cos? Chris? Great. And then again, I make sure I'm in degree mode in my calculator, and I enter in sine 0, sine 90, sine 180, and so on. And then same for cosine to generate the y coordinates. Okay? So those are our 7 main parent functions that I went over in the various units. I think, if I'm not mistaken, I think that in the transformation section, I take all units that we did transformations and I put them into the transformation section of the exam, if I'm remembering back correctly. So you might see like a trig function in the transformation section of the exam. So those are our parent functions. We're going to focus mainly on these 3 from Unit 3 today because we're doing Unit 3 recap. Okay, and there is a specific order that we want to make sure that we do transformations into. And if we think about our transformations function, we talked about in class that if I just go left to right with the transformations A, K, D, and then C, it will actually take care of the order of transformations for me. So we'll go A, and then we'll go K, and then we'll do the D and C transformations. That makes it so that I do all flips or reflections, stretches, and compressions first, and then all shifts, C and D, last. The reason for this is dead mass, right? A and K are multiples, whereas D and C are additions and subtractions. So I need to make sure that I do multiplications before I do additions and subtractions, right? Okay, so we worked in describing transformations in words and identifying A, K, D, C, all of that good stuff. So what do I have out of A, K, D, C? Let's start with that. In this transformation function? Maya?
A is 2.
Mm-hmm.
D is -2, which would be +2. Or sorry, no, K would be.
Very good.
And then C would be.
How did you know that this was a C and not a D?
Because the D would be inside the bracket. Yes.
Perfect. So we know that that's a C because it's outside the brackets. K and D must be inside the brackets. We can see that here. Okay, what does an A value of 2 do to our function? Matt?
It's a root by a factor of 2.
Great. I'm just going to say BAFO for by a factor of. K of -2, this actually does 2 transformations. Josh?
Horizontal flip.
Horizontal flip or reflection. And
And then a vertical compression by a factor.
Horizontal. Horizontal.
Oh yeah, horizontal compression by a factor of 1/2.
Very good. Horizontal compression by a factor of the reciprocal of K, so 1/2. Why don't I put -1/2? Maya? Absolute value of K. Part of the reason for that is that the negative part is the flip part. The half part is the compression part. So we split those up into 2 different transformations. I think this one's pretty easy. This is just shift down 3 units. Okay, just as a reminder as well, when we go to do transformation calculations, I think we've done this a lot in this course, so many of you probably remember this already, but just as a recap, what are the tops of these equations? I'm not talking about in relation to the question we just did, but what are those general equations that we can use to calculate our x's and calculate our y's? Ella?
Reciprocal of K, X plus D.
Perfect. Reciprocal of K. So when we say 1/K, it just means reciprocal. So 1/Kx plus D, and then what's the other one, Ella?
AY plus D.
Very good. And if you happen to have asymptotes, horizontal asymptotes will always shift up and down with the C value. Vertical asymptotes will always shift to the left and to the right with the D value. So we have asymptotes in the functions 1/x. We have asymptotes in the exponential functions, which I actually forgot to add to our list here. So these both have horizontal asymptotes along y = 0. Okay, and then we know if we do transformation to those that will shift up and down with the C value shift. Okay, so this is a good example because it's one of the more challenging functions that we worked with in Unit 3. The 1/x function, and then we have transformations. We have an A, a D, and a C. So I'm going to start with the parent functions, the parent function points of 1/x, which we said good x's to choose would be -2 to +2, but instead of including 0, we include the -1/2 and the +1/2 points. And when we sub them into 1/x, we will get -1/2, -1, -2, 2, 1, and 0.5. Again, I'm just taking these and I'm plugging them into the function to generate the y's. Who wants to set up our equations for us here? Josh?
So the x minus
Good?
And then 2y minus 1.
Good. So I appreciate, Josh, that you remembered to switch the sign of the d value. It becomes plus 1. And if we had a k, we would have done the reciprocal of that to plug that into that equation. So we're just going to take a second. We're going to take all these x's and subtract 1 from them. That should be pretty quick. So we'll get -3, -2, -1.5, -0.5, 0, and 1. Then we're going to take all of our y coordinates. We're going to multiply them by 2 and subtract 1. So -1 minus 1, that gives us -2. -2 minus 1, that gives us -1. -4 minus 1, -5. 4 minus 1 is 3. 2 minus 1 is 1. And 1 minus 1 is 0. What are the new locations of the horizontal asymptote and the vertical asymptote? Think about how this is shifted up and down, and think about how this one has shifted to the left and to the right. What's the upward or downward shift here? Kim? Yep, so we have a shift of -1 for the y. How about x? Also -1 because the d value is -1. So this one we want to look at the c value. This one we want to look at the d value. Okay, so I'm going to pencil both of those in. I have a horizontal asymptote at -1. That's this one right here. I'm going to label it with its equation. And then I have a vertical asymptote also at -1. And I'm going to label that with its equation as well. And then we should get, if you guys remember these functions, we have usually two curved points that are, or curved pieces that are diagonally across from one another. So I should get two pieces that are on opposite sides diagonally of both of those asymptotes. So just make sure as you're graphing that you are getting points that make sense. And don't cross over asymptotes or anything like that. Something is wrong here. I miscalculated this one, because that crosses an asymptote. This should be -3. See? It's good to draw the asymptotes, because then you'll know if you got something wrong. Which one is, this one's 5. Okay, so that's the first piece. And then I should expect that we get kind of like a reflected piece over on this side over here, if we've done it correctly. Which I think we do, so that's good. Okay, you're always going to make sure with these graphs that you curve them toward the asymptotes, but don't cross over the asymptotes, don't touch them. We also worked with transformations in combining these two equations. So this one was a little bit trickier because it's the 1/x function. We should see our final transformed function looking kind of like this. A is on top because it gets multiplied into the numerator. And then k and d always go wherever x is. In this case, x is in the denominator. So k and d will go in the denominator. So can somebody make my equation with this general skeleton equation and these transformations? What would that look like? I think A is pretty easy to fill out, right? We can just put 2 on top in this case. We don't have a k, so we can kind of ignore that. I will just recopy this exactly where this is, so it'll be x plus 1. And then I'll add or subtract whatever c value is out here, so that's -1. And this is what I would label my graph with. So we'll label it as g at x equals 2 over x plus 1 minus 1. Okay, this is not a formula. This is just like a way that you can kind of remember where to put AKDC. In general, this comes from the fact that we put A and C on the outsides, and then we put K and D wherever X go. So in the end, we end up multiplying that A value into the top. That's why we end up getting that A on top like that.
why doesn't the initial equation look like that?
So this one gives us like the parent function separate from the transformed function. Like this is saying like take whatever parent function you have f at x and perform these transformations on it. And then this tells you what parent function you're starting with. And then like the one that we make is the combined version of that. I could give it to you like this, and then you would have to pick out the parent function from that, right? Okay, in this unit, it's probably also good for us to recap inverse functions. So the process of finding an inverse is 4 quick steps. Replace any function notation. Some of you guys did this for your video tutorials, so you might recognize this. Replace any inverse, any function notation with y. Swap all x's and y's. Re-isolate for y. And then the last step is replace y with inverse notation. If the function is f at x, you'll replace it with f inverse of x. If it's g at x, it will be g inverse of x. Okay, so let's do the steps here. We're going to replace the function notation with y, as it says in the first step. We will swap the x's and y's. That's the second step. So wherever you see a y, replace it with an x. Wherever you see an x, replace with a y. And then the big part here, which is like what you kind of learned in grade 9, which is the algebra part, is we need to isolate for the y on one side. When you isolate, you must do bedmass in reverse. So the first thing that I'm going to look for are any additions and subtractions that are not inside a bracket. Because as soon as I go inside a bracket, bedmass sort of resets again, right? The bracket will be the last thing that I touch before I get inside that bracket to move other things. So additions and subtractions need to move first that are outside brackets. So this needs to move first. It goes to the opposite side. We switch the sign when we do that. So I've taken care of additions and subtractions that are not inside brackets right now. Now we'll go to divisions and multiplications to get rid of those. Again, they need to be outside brackets to start, and then we'll work our way toward the bracket. That will be the last thing that we work our way inside. I could divide by a half, but I think it's a lot easier just to multiply each side by 2 to get rid of that half. When I do that, I'm multiplying this entire thing by 2, so you see that I put brackets around that. And then these will cancel. The 1, we can just drop that out, of course. Now I have this. Now I'm going to go for exponents. So how do I get rid of a squared? Square root. What's the special thing that we need to remember about square rooting when we do inverse and solving for a variable by undoing a squared? Remember we talked about how x squared equals 16 has 2 answers? Plus or minus. So you need to remember to do that. I don't need to do that over here because these are going to cancel anyways. So those are going to cancel out. Then I will work my way inside the brackets. So I can kind of drop the brackets now that we've gotten rid of everything outside. And the process will restart, right? So now that we're at brackets, we can restart the process. So get rid of any additions and subtractions, which would just be -3. So I'm going to move that to the other side. Make sure that it doesn't go underneath the root. It would be +3. Last step, I'm going to replace y with inverse notation. So f inverse of x. You can either say +3 plus or minus the square root of 2x minus 1, or you can leave the +3 there. It's up to you. I usually just do this because it's a little bit, just makes more sense mathematically to think about it like 3 plus or minus this. But it doesn't really matter. Okay, so that is the process of finding an inverse. And sorry, this is step 3 here. Okay, let's talk about graphing inverses now. If I want to graph this inverse function, I actually don't even need to be able to correctly find the equation of the inverse. If I can figure out transformations from the original function, what did we talk about doing with the original function once we've transformed it? What's the quickest way to find the inverse points? Ella? All you have to do is swap the x and y. So what's the parent function of f at x, the starting function here? If I took away all the multiplications and additions and subtractions here, what remains? Cam? X squared. So the parent function of this is x squared. Maybe we'll say g at x equals x squared. So I'm going to start with those parent functions, and then I'm going to do transformations to this function. So this is the function. This is the parent function. So if I want to do parent function points, we talked about good set of x coordinates to be -2 to +2, and then we square each of them to get the y's. So I'll get 4, 1, 0, 1, and 4. Then I'm going to do transformations based on this function. What do we have out of AKDC here? We have a D and a C. And did you say something at the beginning of that? A. Okay, so this is an A. How'd you know that was A and not K? Yeah, it would have to be in the brackets underneath the squared if it was a K. So we will do x plus 3, switching the sign of this D value here, and half y plus 1. I'm just going to do that really quickly here. So 1, 2, 3, 4, 5, and 3, 1.5, 1, 1.5, and 3. So those are my f at x points. So this asks us to graph f at x and the inverse. So I'm going to start by graphing f at x. There's no need to graph the parent function of this. It's not asked for in this question. And I'm just going to go by a scale of 1s here. I think that's, actually maybe we'll go by 0.5s, so every other. All right, so quickly, 2, 1.5, 3, 1, 4, and 5. Here we go. Here's our base function, or transform function to start with. The inverse function, all we need to do for the inverse function is just swap the x and y coordinates from above. So it will become 3, 1.5, 1, 1.5, and 3, and then 1, 2, 3, 4, 5. So I'm just going to graph those new points here. It's okay if the graphs overlap. They will in this case because I'm reflecting it over that diagonal y equals x line. That wasn't it that I graphed there, but there it is right there. I reflect over that line. So it should have a piece that gets reflected down and a piece that gets reflected the other way. 1.5, 2, 1, 3, and then, did I do something wrong here? 1.5, oh yeah, and then 1.54, yeah, that's fine, that's 5. Okay, so that is f inverse of x, and I'll graph this one. I'll label this one as f at x. Okay, graph as usual, do transformations, then just swap the columns of your x and y coordinates, okay? So that's kind of the basic recap. I know we didn't do a square root function here, but I think you guys kind of have the general recap of everything. You just use the square root of x parent function points if you have that as a parent function. I think it's good that we reviewed inverse functions as well. And then we will, after the break, we'll talk about exponential functions. So I'll give you guys some time now. You can do some of your work. If you're doing